Hello, everybody. Today, this is Pre-Algebra, Chapter 2, Lesson 8. Today, we are talking about the distributive property. All right, I want you to imagine something for a second. I want you to imagine that there's a teacher. Here she or he is. The teacher has some apples. Well, let's make the apples red. Has some apples to give her students. Don't worry about the number of apples. Let's just imagine she has this basket. There's an undisclosed or maybe infinite amount of apples in that basket. But this is how it works. Every time she walks up to a door, a classroom, right? No matter how many students are in that classroom, she must give the same number of apples to each student. So what I mean by that is, let's say there are 5 students in this first room, right? We've got 1, 2, 3, 4, and 5. Our teacher walks up to the room, she knocks on the door, and she says, "Hi guys, I've come to give each of you an apple." And she says, "How many people are in this room?" And the person in the front says, "Oh, there are 5 people in this room." So she says, "Okay, great. I'm going to give you each one apple." So she uses something called distribution. She gives or she distributes one apple to this person, one apple to that person, one apple to that person, one apple to this person, one apple to that person. This is the teacher who gives one apple per person. No matter how many people in the room, every person is going to be distributed or given one apple. Now here's another teacher. This teacher gives 3 apples to every student in a room. So let's say she goes to a different room, right? Room number 2. Room number 2 has only 3 students in it. Well, this teacher who gives away 3 apples to each student walks up to the door, knocks on it, and says, "Hey, how many students are in this room?" The first person says, "Oh, there are 3 students." So Miss 3 Apple says, "Ah, that's great. I'm going to give each of you 3 apples. Here's 1, 2, 3 for you. Here's 1, 2, 3 for you. And here's 1, 2, 3 for you." So no matter if it's teacher number 1 or teacher number 2, teacher number 1 gives the same amount of apples to every student in a room. Teacher number 2 does the same thing. She gives 3 apples, a consistent number of apples, to each student in each room, okay? That is the basics of the distributive property. Let's talk about it in terms of math, okay? We know that when we are doing our algebraic expressions or our number expressions, if we have a number on the outside, sorry for a second, if we have a number on the outside hugging a parentheses, let's say 3 plus 2, we know that what this really means is 5 times whatever is inside the parentheses, right? So in reality, this is 5 times whatever 3 plus 2 is. If we know that, we also know something else. So let me show you what I mean. There's another way you can think about this. Sure, you can use a dot to express what you're talking about, but that's not what I'm saying. What I'm saying is there's 2 ways to solve this problem. You can either do the parentheses first and say, okay, 3 plus 2 is 5. 5 times 5 is 25. That's the first way you can do it, right? You can use PEMDAS and you can just solve what's in the parentheses first. Or you can use what we just talked about called the distributive property. So just like the teacher, there's the teacher out here and she has some apples. And her rule is that she's going to give 5 apples to everybody in the room. Where's the room? You can see it. It's right here. It's the parentheses. So she goes and knocks on the door and says, hey, how many students are in the room? Well, the first student says, well, there's 3 in the front and 2 in the back. So she says, that's great. So I'm going to give 5 apples to each of those students, right? So she gives 5 apples to the 3 students in the front, and she gives 5 apples to the student in the back, okay? So now what's basically happened is that the first students in the front, the 3 of them, each of those 3 students has 5 apples, or 3 multiplied by 5. I can draw that out for you. Here's student 1, here's student 2, here's student 3, right? Or let's make it numbers. Here's student 1, 2, and 3 in the room, right? Each of them has 5 apples. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay? Then that takes care of this. Then she also gives 5 apples to the students in the back. So we've got the 2 students in the back. Here's student number 1 in the back and student number 2 in the back. And both of those students both get 5 apples as well. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So now our operation says you add those 2 numbers together. So let's add them together. So you have 5. This would be another 5, which is 10. Another 5, 15. 20. 25. Look at that. No matter what, you're still going to get the same number. We've distributed the 5 apples to the 3 students in the front and the 5 apples to the 2 students in the back, and then we added them all together. A simpler way of thinking about this, if the visual of the teachers and the students in the room doesn't work, is simply to do this. Same problem using the distributive property. Let me show you. Here's how it's going to go. Same exact problem. This is another way to think about the distributive property. Might even be easier. Sorry, I got peanut butter stuck in my mouth, it looks like. So all you need to do is this. When you see the number on the outside, you know it's multiplication, right? So you say, okay, 5, I'll use red for multiplication. 5 times the first number and 5 times the second number. What I like to do is I like to rewrite it so it comes out easy. So 5 times the first number is 5 times 3. I drop the symbol, so I stay consistent. And then it's 5 times the second number, 5 times the second number. So I solve these out. 5 times 3 is 15. Drop the plus symbol. What is 5 times 2? 5 times 2 is 10. 15 plus 10, 10 plus 10 is 20, plus 5, 25. Now, I know what you're saying to yourself. The distributive property method, which is this one over here, it looks like a lot more work than using PEMDAS, right? But it's the same actual mechanics going on in both. The distributive property is just showing you another way to use PEMDAS, right? This is PEMDAS. You start with the parentheses first, and then you solved whatever was inside it, and then you multiplied. And then this is distributive property, which is essentially doing the same thing. Distributive property. It essentially does the same thing, but it's a different style, okay? Let's do another problem. Let's try, here's a good one. 2 times 3 plus 4. In fact, here's what we're going to do. I'm going to show you using PEMDAS first, and then I'm going to show you using the distributive property, and I'll show you that we get the same answer. Distributive property. I would like you, if you're following along with your notes in my class, to please write these down. So here is the problem. We have 2 parentheses, 3 plus 4 on this side. And we're going to do the exact same problem on this side. But we're going to use the distributive property over here. Okay, so on the first one, let's use PEMDAS. We start with our parentheses, right? Do I have parentheses? Yes, I do. 3 plus 4 is 7. Keep them. Then I have multiplication. 2 parentheses 7 is the same thing as saying 2 times 7. 2 times 7, that's an x, for those of you wondering, sorry. 2 times 7. And then 2 times 7 is 14. Okay, so we didn't have exponents, we did have multiplication, we didn't have division, addition, or subtraction. We got 14 using PEMDAS. Now let's use the distributive property. All right, so I know that this is saying 2 times whatever is in the parentheses. So what's in the parentheses? We have 2 times 3, and we have 2 times 4. Okay, I'm sorry for writing a 4 there. 2 times 4. We're going to distribute the 2 to the 3 and to the 4. Another way to write this, perhaps a more clean way, is like so. 2 parentheses 3 plus 4. Just so I remember what I'm doing, it's multiplication here, and it's multiplication here. And then I like to draw these little arrows at the bottom. So 2 times 3 is 6. And then drop the plus sign. And then 2 times 4 is 8. Then all I have to do is 6 plus 8. 6 plus 8 is 14. There you go. You got 14 on both edge. Both ways work. You can use PEMDAS or you can use the distributive property. Let's try another way. Remember, if you need to get these into your notes, please pause the video and copy it down. Last one, or let's do 2 more. Let's try, here's a good one. We'll do PEMDAS over here. And we'll use the distributive property again over here. Distributive, which means to distribute or to give. Everyone gets equally over here. All right, so the problem is 2 times 7 plus 3. And we're going to write the same problem over here. And now we're going to use our 2 different methods to solve this problem, right? All right, using PEMDAS, let's solve the parentheses first. 7 plus 3 is 10. And then we have the 2 on the outside. 2 parentheses 10 is really 2 times 10. 2 times 10 is really 20, right? All right, now let's see how we can do this using the distributive property. Well, I know the 2 is going to be multiplied by the 7 because of the parentheses. It's hugging in on the outside. So it's 2 times 7, which is 14. Drop the addition sign or whatever operations are in there. And then 2 times 3, which is 6, right? 14 plus 6 is 20. There you go. Nice, simple, and clean. Either way, you're going to get 14 plus 6 is 20, or 2 times 10, which is 20. Let's try one last one. Actually, I'm just going to erase it so I don't have to draw everything again. Let's try one last problem. Okay, let's do 8 times 3 minus 2. Now we have a negative symbol. And we have on this side 8 times 3 minus 2. Same exact problem. All right, let's try using PEMDAS first. Start with the parentheses. Do I have parentheses? Yes, I do. I've got 3 minus 2. 3 minus 2 is 1. I've got 8 parentheses 1, which is really 8 times 1. I don't have exponents. I do have multiplication. 8 times 1 is 8. No division, no addition, no subtraction, right? Let's try the other side. Okay. This is really 8 times 3 minus 2, so I can distribute the 8. 8 times 3 is 24. Drop the negative sign because I didn't use it. Then I have 8 times 2, which is 16. All right, now I have 24 minus 16, which is 8. And there you go, ladies and gentlemen. Whether you use PEMDAS or the distributive property, you will get the same answer for both. Distributive property literally means it because we took the outside number and we distributed it to everything inside. 8 times 3, 8 times negative 2, or we could have used PEMDAS. 3 minus 2 first is 1. 8 times 1 is 8. All right, hopefully that helped. We will see you in the next video. If you have any questions or you'd like me to re-explain something, please put it down in the comments below or send me an email. We'll see you later.